Hey everyone, today we'll be going over what is artificial intelligence all under 5 minutes, and without any further hesitation, let's get started. Before we go any further, we first need to ask ourselves, what is artificial intelligence? Artificial intelligence is every aspect of learning or any other feature of human intelligence where a machine can simulate it. And this is the premise for our video. And the foundations for what we have now on the present definition of artificial intelligence can be pinpointed to, initially starting off with Warren and Murkoch and Walter Pitts, who laid down the foundation for the idea of neurons and how they can be applied within mathematical foundations and theories of computation. And the term for artificial intelligence was first coined at Dartmouth in 1956, where there was the Dartmouth Summer Research Project on Artificial Intelligence, where the term artificial intelligence was first coined. Afterwards, in the 60s, there was a unique boom in funding for artificial intelligence research. However, there was an unfortunate amount of funding, particularly in the 70s, also known as the AI winter, where DARPA and actually the Lighthill report already stated that given the fact that there weren't that many feasible applications during the time, they cut funding necessarily for artificial intelligence research. Now, in the present case of application for AI, it is still malleable, given the fact of stakeholders who are interested in the applications of technologies and seeing it as a medium for revenue. And in the current context of AI, there's a lot of hype around generative AI, but however, there is a lack of understanding about the fundamentals and the disciplines and history and domains that really go into the subject of artificial intelligence, which should be respected when creating new products that will impact people on a large scale. And when creating new applications in the premise of artificial intelligence, we must go back to the bare foundations of the people who established the field before, where artificial intelligence is every aspect of learning or any other feature of human intelligence where a machine can simulate it. Well, what do we mean by the context of intelligence? Because human intelligence can apply on a broad range. The foundation of artificial intelligence can be traced down to Principia Mathematica over how ideas and logic are represented. Then it's already built on Pritt's work of neurons, and then we also know about Minsky's and Pepper's work for the perceptron as well, for us to be able to build the foundation necessary for what we have in the current field. Now, in computer science, we already have the necessary software tools to be able to simulate neural networks, and knowing exactly how neurons are trained within a neural network, built on premises of language that has a comprehensible syntax, as well as how we can simulate such training from different libraries. Now, understanding how the different domains of artificial intelligence have been organized over the decades, we can already determine, based on the premise and foundations of how neural networks are made, we have general AI, machine learning, deep learning, and the different domains of software engineering can utilize different disciplines of artificial intelligence, depending on the complexity and computation of the following tasks, such as natural language processing and computer vision. Now, in the context of software, this largely revolves around system design and how well the model can actually scale on a larger impact. We also need to take into consideration of how effective a model can be trained within the premise of data, depending on the domain and usage of artificial intelligence, and how a following neural network should be trained. If we are training with new software models with new data to simulate human intelligence, we need to figure out how exactly it will interact within legacy systems, and then also rely on reliability, scalability, and performance, and then consider for fault tolerance as well. But really, we need to ask ourselves, how will the full stack application actually perform? And in the context of hardware, we also need to take into consideration of what type of scaling. We have vertical and horizontal, and then we also need to consider the logic design, understanding what specific hardware is going to be used to develop the AI models, the memory capacity, since we're going to need high-speed memory efficiency to be able to call upon different caches, or also recall different interactions within the model and the given client. And we can also consider parallel processing to simulate computation between GPUs, TPUs, or multi-core processors, but mostly GPUs and TPUs for model training, testing, and validating. And also consider power efficiency and specialized hardware at the same time. And given the fact that we are focusing on application base, we also need to appease the stakeholders. The premise is, can it generate stable recurring revenue? And there will always be consistent debates depending on what form of new technologies will actually be implemented and how well it will be distributed. Now, the future and direction of artificial intelligence is ultimately up to you, because artificial intelligence is a tool. We are using it to be able to simulate human intelligence, whether in the context of intelligence and learning for a machine to simulate. Hey everyone, thank you very much for taking time to watch this. If you found this video helpful, be sure to feel free to please like and subscribe. If you have any other questions, please put them in the comment section. And as always, take care. Cheers. Bye-bye.